Hello, Honors Chemistry, and welcome to Chapter 2, Section 2.2. What we're going to do is, since this is our first real chapter, right, Chapter 2, this set of lectures will contain some references to, like, the formatting of your book, things to pay attention to in your book, right, and just extra little things, right, that since we're just starting off the school year, that are important for you to know, okay? Every lecture from here on out won't contain those tidbits, right? Just this first one while we figure out our bearings, right? So first, this is your lecture, right? This is where you are going to get the primary source of information. Well, actually, no, that's not true. Step one, you read the book, right? And that's like your first exposure to the information, right? Some of it you'll get right away, some of it you won't, which is fine, right? And then step two, you'll watch the lecture, right? That's exposure number 2. More of it will sink in. We will cement the things you already knew, right? We should start to clarify the things that were still fuzzy, right? And I will typically work through these skill builders, right? The practice problems, right? Especially if I think they're a little bit challenging, right? I will work through them in the lecture videos, right? So this should help to start to clarify anything that's fuzzy. Then what's going to happen is you're going to bring all of that knowledge to class, right? And you'll be able to apply it to some practice problems or some questions or something, demonstrations, whatever else that we're going to do, okay? Now, what's also important, since this is your lecture, right? If something's fuzzy and you need to pause it, right? And make sure you take very good notes, right? There is no reason for your notes to be lackluster when you're listening to a lecture on your own time at home, and there's a literal pause button, all right? In addition, right, if you feel like you are advanced enough and you understood it really well, I don't fault you for watching it on double time, right? But again, make sure you're taking good notes, right? In addition, right, do be mindful that because this is your lecture and we're not sitting here staring at each other, if there's something that you don't understand, right, mark it so that way you can ask a question about it, right? Whether it's something you didn't understand that I said, right, or something that's still fuzzy, like a concept that's still fuzzy, right? Mark those things, right, and make time to come and ask them, all right? So anyway, starting with scientific notation, this is a refresher. I'm just going to do some highlights on scientific notation. I think you are also refreshing on this in math class. If this is something where you're just like, oh my gosh, you need to see me sooner than later, okay? So scientific notation, right? So this is just a matter of expression, right? When we take something from standard notation to scientific or back and forth, right? We are not changing anything about the value, right? We are just changing the way we are representing that number, right? So for example, starting here, when I say 2.5 times 10 to the positive 6, right? Positive 6 means giant number, yes? This means 6 places larger, right, than what we see written on the paper, right? And I know some people like to say, move it to the left, move it to the right. But you know, right, a lot of us know that sometimes we aren't so great with left and right. But we are pretty good about bigger and smaller. I am anyway, right? So if you're really great with left and right, you keep on saying left and right. But I like to say 6 places bigger, right? Which means that I'm going to, wherever I am, I'm going to move 6 places bigger, right? So 2.5, 6 places bigger is 1, 2, 3, 4, 5, 6, right? Which means that I'm going to fill in 5 extra zeros, right? And this is the actual number that I'm describing, right? So whether I say it this way or this way, they're the exact same number, just expressed differently, right? Here, right, when we're talking about 2.5 times 10 to the negative 6, right? Negative 6 means 6 places smaller, right? That's what that scientific notation says. So that means from where we stand, 2.5, I need to go 6 places smaller. 1, 2, 3, 4, 5, 6, which means I'm going to add 1, 2, 3, 4, 5 zeros to the front end of that value, right? So this number and this number, again, exactly the same, just a matter of how we express it, okay? So then going in the other direction, right? So let's make sure we can take standard notation and put it into scientific notation. So this is 1, 2, 3, 4, 5, 6. Right? So I think we all implicitly understand, first of all, whether you've ever thought about putting it into words. When we write scientific notation, this number out front needs to be greater than 1, less than 10. Yes? Greater than 1, less than 10 for it to be a proper expression of scientific notation. Okay? So if we look here again, so this was 1, 2, 3, 4, 5, 6 places to get us to 1.23. Now, 10 to the 6th, right? But it's smaller, so negative 6, right? Because sometimes people get confused about, do I make it negative or positive? Well, is this a small number or a big number? Right, it's a small number. Negative exponents, right? Negative exponents, negative exponents represent numbers less than 1. Yes, or we could say negative exponents represent decimals. Yes, negative exponents represent numbers less than 1, or we could say that negative exponents represent decimal values, right? This is a number less than 1, a decimal value, which means that this should be a negative exponent, right? And then last one to give us a point of reference, right? We have 1, 2, 3, 4, 5, 6, 7, 8 places, right? So 1.23 times 10 to the 8th, and I know in this case that it should be a positive 8 because this number is bigger than 1, right? So it should be a positive exponent, right? Does that make sense? All right, so this is our quick primer on scientific notation. Do note for the rest of the school year, if a number has more than 3 zeros, right? So more than 3 zeros, in either direction, so more than 3 zeros on the front end or more than 3 zeros on the back end, it must be expressed in scientific notation. Yes, if it has more than 3 zeros on the front or the back, it must be expressed in scientific notation. All right, make sure you tuck that away. We will be using numbers of very large and very small quantity all year, so make sure you're good here. All right, thank you for listening. Stay tuned for the next section where we start doing some math with our numbers and counting significant figures. All right. Thank you for listening. Be good, and I'll see you soon. Bye.